Mic check. Mic check. So let's go ahead and first we're gonna back up our project. Actually, we should do that at the end. So we'll actually do that later. So we're gonna cd Canasta main, copy that, okay, so we're working on determining which methodology we're going to use. Meaning, are we going to use timestamping or incremented change ID? And I think one of the biggest issues with incremented change ID, well, that would mean we would be accessing an attribute that's available. It would have to be available to all of the various class, the instances of all the various classes, and yeah, it just like the same purpose would be served by a time, and that timestamp would be easier. Issue. This attribute would have to be accessible by every other class, instance, player, game, etc., which would be difficult to implement, and I also don't see any reason to use this system over the more simple timestamp system. Yeah, so I still feel like timestamping is going to be the way to go. It just seems like a good option. Last time we hit a crash bug that I'm pretty sure was already existing from a long time ago. We are not going to be working on that. We're going to finish this timestamp implementation. So let's read our note here. So to implement this, we would have to either add the timestamp as derivatively assigned via calculated properties or via direct subsequent assignment in places where the data is directly changed. We stopped there. Okay. We but begin implementing this code after more brainstorming and fleshing out the final process. Make sure these timestamps will have a way to actually be used at the endpoint in our 100% solution before implementation. Okay, true. So let's try to flesh this out a little bit more before we actually start writing code. So well, first of all, let's look at what we already have. Let me see. We already have some of this as the time dictionary. So let's go to client, which is already open over here. I don't know why it does that. It should be smart. VS Code should be smart enough to know. Well, it worked that time. I guess it depends on which side you have active. If you have this side active, it will open up. If it's not open, it will open up the file. But if you have the side of the editor open that the file is already opened in, it will just bring you to that already opened file. Now, so we have this time dictionary, and it is a dictionary. It's updated in DirtCheck. It contains all the timestamp data for the various items transferred over the network to ensure proper data assignment. So we actually already do this, but with the system that we have in place, it's really to make sure we're not overwriting old data. It's like the opposite. So we're making sure that we're not overwriting a newer change with an older change. Meaning, like, if we modify a value on the client side and we go to send it over to the server, and in the meantime on the server, further along in the process of things, correctly changes that same data point at a later time. But because it gets received after that change on the server side, it will apply that change if we don't check the timestamp. But when we check the timestamp using the time dict, we see, oh hey, actually this change that's trying to get pushed from the client happened at 11:03, but we made this change at 11:04, which usually means, almost always, like, yeah, it actually always should anyway mean that it's a more modern change, and we don't want to apply that data because that was an issue in the past. Okay, so with that out of the way, now we know what the time dict actually is, and let's look at some of the code associated with it. So this is in the DirtCheck function in the client file, which is used. This function is used both in client and server side. It is the main function used to determine whether or not data needs to be sent, and also which data needs to be applied, and the logic to apply the data. So this is our time dictionary, which we reassign right here because these are simple variables, meaning that they get updated frequently, and if we were not to reassign the key with the associated updated version of the value, meaning like the new timestamp, then we would be referencing old data. So we have to reassign it right here. I'm almost 100% certain of this. We tested that a couple times, and like, I'm still not 1000% certain that's how it works, but I'm pretty positive. So just because I'm not absolutely sure, and I should be, we'll just go to test reminders and we'll do this real quick. We'll make a list, or actually we'll just make a dict, dict. We'll say A is B is 2, and then C is 30. Well, actually we'll do it like this. We'll say A equals 1, B equals 2, and then C equals 3. And now we'll just say it's A, B is B, and C is C. So then we're gonna print D, but after that we're gonna change C to 4, and then we're gonna print D again, and we expect it to be see, it prints the same thing twice. It doesn't reflect the change made to C. So if you want this dictionary to always reference the current value, as far as I know, you have to update the dictionary. You would have to say D equals, and then like do it again. But really, since you only change C, you would just say D at C equals C, and then when you do this, when you run this file, now, oops, okay, now it should be showing the correct value. Now it shows A is 1, B is 2, and C is 4. But like, this isn't always the case. For instance, let's say if C was a list. If C was a list of 3, and then we modified, let's see if we did C dot append, and we appended 4 to it, because we're not actually reassigning. Refers to we're not reassigning the namespace, we are modifying the data at the namespace, then it will work correctly without you re-referencing C. So there's a difference there, but we're gonna leave this like that. And yeah, alright, so now we're gonna comment all this out. We're gonna go back up here, and I'll put the date 3/25/24. Reminder that it's fucking cold in this house because David likes to freeze. But also, it's a reminder that if you have a variable as a value in a dictionary, and you reassign that variable's namespace to a new data object, whatever you want to call it, the associated dict value will still refer to the old originally assigned data. If you want it to be current, you have to reassign the key value pair every time you reassign the variable. Alright, so done, that's reestablished. Now I'm sure again, because I forgot, so we're gonna go back to main. And then from here we can figure out, let's go back to search, and we're going to figure out if this is what we're going to be using for our timestamping. Like, because if we do use these, well, these are timestamps that are already implemented, and they should probably exist. I mean, they probably already exist everywhere that they need to exist. So this is so this would be, I think, a great place to implement this system, since that is exactly what this is already. It's just been used for a different purpose. Now the question is, well, if we convert this to have a broader application, will it interfere with its current usage? And I don't think that it would, because the usage now is for it to reference timestamps, which are currently reassigned every time the associated value, in this case input text final, is changed. The timestamp is also updated to reflect the time at which it was changed. The only difference in what we're trying to use it for versus what it's already used for is what it is compared against. We are comparing the timestamp on the server side, or whichever side, you know, is the time dict is being referenced from. It's comparing it against the incoming time dict entry for the associated value. So this is just going to be like we're going to be using these timestamps to determine which data should be applied first, instead of should the data be applied at all. So I don't see any conflict as I'm talking through this and thinking about it. I don't see that there would be any conflict. And like I said, it saves us work, like it's already partially done. As you can see, all of this for the game, the CG stands for current game, and that refers to the game object. So currently, much all of the pertinent game object attributes have associated timestamps implemented. And what we would have to add would be we would have to add all of the player attributes, maybe more of the game attributes, then all of the deck, and then the location attributes. So the question then becomes, what exactly do we need to transfer? I mean, meaning which attributes actually need an associated timestamp. So we'll say this is going to be our number one thing. So we need to figure out step number one. We need to, we don't have to just leave it like this. Step number one, determine which, and actually I'll put we can use the pre-existing cl.timeDict, since this is exactly why we created it in the first place, and it also has lots of the adders already implemented. After reviewing the logic / brainstorming, it seems like we can safely use the pre-existing, and that will be what is going to go in our devlog down here. So we're going to put brainstormed DTM, brainstorm possible solutions for more precise modification pertaining to timestamp or pertaining to data application to orderly data application. So brainstorm possible solutions for more precise objective, and then we put reviewed the logic reviewed the logic of the existing client.timeDict and the brainstorming the requirements of the DTM additions we would need to create for more precise timestamping. It seems like we can safely use the pre-existing, since this is echo back we created in the first place, and it also has lots of the attributes already implemented. So then we'll put created and outline for implementing system from beginning to end. So that's what we're going to do before we actually write any of the code. We want to make sure that we have it mapped out completely. So step one is going to be, of course, determine which attributes we need to create timestamps for. This is going to be for player, game, locations, deck, maybe even client, server. Okay, and then we're going to do step 2, which is create or determine if already created. Create the associated timestamp logic for each adder, or determine if it has already been created. Okay, and then step 3 is going to be what? So after we actually create the associated timestamp logic for each attribute, then we have to figure out a way to have to ensure, figure out a way, most likely cl.timeDict, to transfer. Well, actually, okay, so really the step that I'm trying to figure out how to word this exactly. We have to figure out a way to, not to transfer it, but well we are going to need to transfer it, but what I'm really concerned about is, so let's go through the steps here. What we're trying to do, we're gonna have all these timestamps every time we update any data. Then we're going to be sending the data over the network, however that may happen. That's going to happen through the dir checks. So currently we have 4 pre-send dir check function calls, and so here's the deal. Whenever we go to send the data, we're not gonna be going off of we're not gonna be sending data based on, and this is a new proposition here because this goes against what we currently have implemented, but this is what I'm thinking we might need to do, is we might be able to, and it might be better to do it this way, is to, instead of just constantly sending, running these pre-send dir checks, and then like basically whichever one it lands on first, it's kind of like roulette. Like, you don't really know. Let's say we change some player data and then we change game data. When we change player data first and then the game data second, it's not gonna know that we need to send the player data first. Currently, if the dir check for player has already been run when we changed that player data, it's not going to get sent first. The game data would get sent first. But what if we made it to where we actually just sent the data? Like, what if we sorted it beforehand? Meaning that like we would look at all of the attributes that had been changed. I'm trying to think. Okay, so this is just a like a brainstorming thing right here. So we're just gonna add this as possibility, and we'll put on sending end pre-sort the changed data timestamp so that so that the proper dir check is run first. Okay, but here's the problem with that. The problem with that is issue. So the issue with that is this would work for the particular attribute, meaning that the first changed would be the first sent. This would work for the particular attribute, meaning the first change would be the first sent, but it would also mean that any other adder from that object would be sent along with it, even if that data alteration happened after data alterations for another object. So if we change the player name first, but then we change the game ID, but then we change the player hand, when we said, okay, we're organizing the dirt check function, it's only gonna send over the player. It's gonna run the player dirt check first, which means it's gonna send it first because the player attribute was technically the first thing that was changed. That means the player hand is also going to get sent first along with it, even though the hand was changed third. So we had the player name first, game ID second, player hand third. But in this implementation that we're proposing, we would still be out of order. Essentially, data application would still be out of order. So we need to put this as a requirement. Requirement number one is the number one requirement is that we apply each and every attribute regardless of source object type, source object, player, game, etc., based on its associated timestamp value. Okay. Yeah, apply each and every adder regardless of whether source object based on its associated timestamp value. So then this leads to another requirement. If I'm, let's see. So, whoa, slow your roll, big dog. Oh, okay. Oh, no. Alright, there we go. Alright, I'm gonna just like sit back and let it cook for a second and make sure I'm not overlooking anything. Slowing down real quick. So yeah, we need to apply based on the specific timestamp, which means we have to well, basically this means we have to restructure our dir check system. Isn't that right? Because currently on the receiving end, when we run dir check, we run in terms of player, game, deck, or location. And that means that we're gonna apply all the player data changes, at once. Even if it's the player name was changed first, and then technically we should apply a game data change next. That's not how it works currently. Currently it's based off of, in that order. So we need to restructure it so that dir check will not necessarily, well, no, yeah, actually, yeah, we would have to restructure dir check, because currently, yeah, that's how we apply. We look at each changed attribute dictionary, and we just iterate through it and apply all the data changes. But what we would need to do is we would basically need to let's figure out exactly how to word this. Well, I guess it is safe to say that we would need to restructure. So we'll put restructure dir check logic. And how exactly what exactly does that entail? Well, it means we need to and here's what I'm thinking now is we can do this in terms of, well, we don't need to optimize, and I'm gonna put this as a note. I'll put this down here because this is going to be closer to step 4, which would be after transferring, we need to sort received data based on timestamp. This means in the scope of all changed data despite source object instead of the current system of sorting based on source object first. Yeah, I mean that's sloppy language, but I know what I mean. So sort received data based on timestamp. So the note that I want to put here for this would be damn, I forgot exactly what my note was gonna be, but I'm pretty sure it was ensure that I'm, oh right, yeah, I remember now. Actually this note then would go before step 3 because we want to make sure we're taking note of this before we start. We've determined if we're going to do this on the sending side or on the receiving side. And I think as a note I'll put, I don't believe it is necessary to sort the data on the sending side since the data would be thrown out of sort since the data would be thrown out of sort via the the network transfer times being, I don't want to say inconsistent, but data size dependent, etc. Yeah. So in other words, we don't, and I'll put TLDR sort data by timestamp on the receive side. Okay. Not send side. Service data based on timestamp instead of current system based on, okay. And how exactly would we do that? Well, let me go back and make sure we have step 1, 2, and 3 up to this step fleshed out. So determine which attribute we need to create timestamps for. Yeah, I mean that's pretty straightforward. Create an associated timestamp logic for each attribute, or determine if it has already been created. That's pretty straightforward. And the issue, let's see, on a possibility for this would be on sending in. We have to change timestamps so that the proper check is run first. Yeah, that we just determined is not like gonna fix the issue. Adder, yeah. So, and then some order, correct. Okay, so then our note, so then we put sort data on the receive side. So we actually just get rid of this. I'll leave that note for now, actually. And we can get rid of the TLDR when we need it. Figure out a way to, so after we determine which ones we did create, we create the actual timestamp. How then, this one needs to be fleshed out more. How do we have to figure out a way, most likely via the time dictionary, to not only to transfer, but to reference and transfer the proper up-to-date timestamps. And this would be done more specifically by, like, okay, so essentially I was thinking like, okay, well, do we just, like when we run this line right here, do we just reassign every single timestamp every time we run this section, and that's how we get our timestamps, like our up-to-date timestamp list. This is how we get all the timestamps in this system. We would basically be able to then check to see, hey, okay, if we have a different value for any, like we can save an old version. Basically we'll create a copy of the time dictionary. So here's a proposition. We'll create a copy of the time dictionary. We create a copy of the time dictionary, and it contains all of the old values. Then update them by rerunning this line, and it's gonna grab, any data that's been changed is gonna now have a new timestamp. So then, I'm just thinking, I'm like, wait a second, that might not be necessary, because all we have to do, like, we don't have to figure this out on the sending side, do we? Because once we receive the data, we're only going to be receiving the data that was changed, and then we're just going to say, okay, for every piece of data that we have received, for every attribute or whatever, we're going to look at each associated timestamp. We're going to look at the timestamp for each one. And we would use the time dictionary to do this. So let me put that. Let's say, I'll just put this as a proposition. We'll say, when receiving data, grab each associated timestamp, each associated adder's timestamp via the time dict, and this would be from the incoming. So yeah, see, now we're getting specific. Now we're figuring out, this is good. So when receiving the data, grab each associated attribute's timestamp via the incoming time dictionary. Then what? Then we would then compare the group of timestamps to each other, or not compare, we would just say then sort the timestamps from earliest to latest. And yeah, so it's just that simple. I mean, that sounds, I think that's perfect. That sounds like what we need to do. So we receive the data as like ink data, then we just grab all of the attributes that have been changed. Now that's going to require some reworking of the logic. Then sort the timestamps from earliest to, I'd say this will require a restructuring of existing logic. And how exactly would that be done? Whenever we, like when we say we grab each associated adder's timestamp. So this means we would have that this will require a time list or some sort on the receiving end. So require timestamp list for some sort. Receiving end. Yeah, I always keep like 6 or 7 by my computer, so when I'm drinking, I mean, as I get thirsty, I don't have to like get up and get a new water every time. So I have like a new rule: a 5-minute break every hour. 4 minutes, then I'm gonna take a 5-minute break. So just keep me nice and awake and everything. Grab some more water, coffee, whatever. Take a little walk. Use the bathroom. Keep my blood flow. So my brain's working. Okay. So what exactly do I mean when I say this will require a restructuring of the logic? That's enough of you, buddy. Your little background noise got old. Okay. This will require restructuring of this logic, and that means like. So basically we would be like, okay, I'm just trying to think, how do we do this normally? We normally would extract, we would normally just run dir check, and it would grab the change data from the change attribute dictionary. But we're gonna have to add more steps to that now, to where all we do, like, I'm trying to think, how do we do this? Like, how do we grab every timestamp? How do we do that exactly? Does this mean we would iterate through each change adder dict? I think that's the answer right there. I think we could iterate through each changed adder dict for the ink data client object. And then basically grabbing the associated timestamp for each adder from the incoming client time dict. Yeah, I think that's exactly what we would want to do. Like, that's feet on the ground. That's the actual process. And that's the goal here. I don't want to be head in the clouds, you know, like I want to actually, before I type a single line of code, I want to know exactly how I'm going to code it and make sure there's no problems with it. So that instead of debugging a bad system, we're going to make sure it's right before we ever write a line of code. Okay, so we can iterate through each change adder for the ink data client object, grabbing the associated timestamp for each adder from the incoming time dictionary, and then what? Then we want to, well, then we would want to sort the timestamp from earliest to latest. Okay, and then, I mean, that's pretty straightforward. Using a simple function, perhaps the one we already made for this, for timestamp sorting, and then I think we'll just put this as position number 3, too. Yeah, so we, after receiving data, grab each associated header's timestamp via the so this is actually step proposition 1. So we iterate. Yeah, after receiving data, iterate through each change adderdict for the ink, or iterate through each, yeah, that's enough, and then put grabbing the associated, or finding, or not finding, accessing the associated timestamp for each adder from the incoming client.timedict. Yeah, that's right. After receiving data, iterate through each change attribute dictionary, accessing the associated timestamp for each adder via the incoming, the received client time dictionary. And I would say this would require we don't want to only access the associated timestamp. We would actually want to append. So we put append the timestamp to a, we could just call it ink timestamp list or something. Append each timestamp to the, or a list to contain the ink changed data adder timestamps. Ink, or the change ink data. The ink data's changed. So what do I do? Change adder. A list to contain the ink data's changed attribute timestamps. Append each timestamp to the ink timestamp list. Okay. And now we're gonna sort. Then we're gonna sort the timestamp in the ink timestamp list. Earliest to latest using a symbol. Alright. So this would be, actually, we're going to change from proposition to step because I'm more confident. This will be step 4. This will be step 5. This will be step 6. And so I think we're gonna scrap this change ID thing. We're just gonna completely get rid of it. put this on devlog. Scrapped the change. What was it called? The change ID. Scrap the change ID increment system. Or idea. Alternative to timestamp. As let me just put scrapped it. As it made less sense and seemed more difficult to implement than timestamp. Yeah. Create an outline for implementing system from beginning to end. This consisted of the actual step-by-step process as far as not simply a idea based alignment. Okay. 3 more minutes. I'm gonna take my little 5-minute break. Okay. Timestamp. Typically by this we either have to add timestamp as derivatively assigned to the calculated properties, okay. And then we'll put step by step actual pseudo, or I don't know if you would call this pseudocode, whatever. It's, determine which attributes we need to create timestamps for. Okay. Step 2: create the associated timestamp logic for each adder. Determine if it has already been created. I don't believe it is necessary to sort the data on settings. Yeah, that's already like established in my mind. I don't need that as note anymore. Step 3: figure out a way, most likely via to reference and transfer the proper up-to-date timestamps. So then we're gonna say that is the way we're gonna do it. So this would just be update the time dict prior to sending data. And ensure time dict is sent. Yeah. Okay, so yeah, we update the client time dict prior to sending data, ensure time dict is sent, then after receiving data,
all day, all night,
then we can put send side,
all day, all
send
night.
side, send side, and then send side, and then this would be Receive guide. Receive side. Receive side. Okay. Okay. Share to send after receiving data. Iterate through each change addict, accessing the associated timestamp for each adder via receive, and then append each timestamp during step 5 iteration to the inc timestamp list, and then sort the inc timestamp list from earliest to latest using simple function. Alright, and then what? What's next? Okay, it's actually time for my time. Go ahead and take that real quick. So oh, and I forgot to post my live.
All day, all night. You blow my mind.
Make sure our
All
link
day,
works.
all night. You blow my mind. All day, all night.
Just this so I can hear it. Associated timestamp for each adder. Share our link works. Client.time date. Yeah, that's right. After receiving data, iterate through each change attribute dictionary, accessing the associated timestamp for each adder via the incoming. Restructure it so that dircheck will not necessarily. Well, no. Does this mean we would iterate through each change? Let's turn that audio down just a little bit. Yeah, so we're gonna turn that audio down just a little bit. It's a little bit loud. Time dictionary, and then what? Then we want to. Well, then we would want to sort the timestamp from earliest to latest. Yep. So everything's working. That's good. Okay. Cool. Link's working. Yep. All right. Cool. Um. All right. Be right back. I'll be back in 5. Got like a little bit of cold. I got like a tiny bit of a fever.
Drink that tea with nature.
It's like I have like a tightness in my chest, and I feel a little bit heavy head. You should download Black Desert Online and try it. They say it's the MMO with the best combat ever. It's like, so you use like combos and everything. Like you can do like left B. One ability will be like left B. It's like a typical MMO, but they have like 25, 30 classes, and instead instead of like only picking like 5 abilities that to use out of a pool of abilities, you get access to every single ability that they have. You just pick which one you use by like whether or not you use it. Um, and the way the combat works is like there's a lot of like iframing and like teleporting, not like necessarily teleporting, but like dodging. Like there's all kind of different forms of dodge and stuff, and like fast movement based on your class. So like there's a lot of like jumping around where you can like it's very like super action, super like fast pace, um, but it's still a typical MMO, and like you use abilities not necessarily by like quote unquote hotkeys. You can hotkey abilities, but lots of them you will use by just hitting like back F or like back B or forward Y. Like it acts like a shortcut for those abilities, and you can combo certain abilities. Like only you can only use certain abilities after you like you use lightning, then you use like lightning storm. You don't have to use lightning storms, but if you want to use lightning storm, you have to use lightning first. If you want to use like fireball explosion, you have to use fireball first. Or you can just not. You can do fireball then lightning. You know, there's all kind of like different things you can do. So I'm gonna go fire now. Yeah, she's so much fun. She's so much fun. What was that thing you just did?
It does DOT.
That's
Oh,
new.
Yeah. Yeah, I don't know now.
It's just a straight up DOT.
Yeah, I think so. But, it's good to throw on and like when you shoot them up and you throw one away and then like kill them. I forgot you can hack your shot right for that.
Is this my water bottle or is that yours on the oven?
That's mine. I think, yeah, that's mine. Is it mostly full?
Yep.
I think I just took one sip of it.
I'll write a D on the cap. I got a permanent marker.
I did that at work.
Yeah, my job. Go ahead.
No.
And like on my job, we have to write the hit number on all the boxes. So like I've used a Sharpie like the entire shift. I will literally like deplete a Sharpie within 2 shifts. Like 6 hours, 6.5 hours of work, and my Sharpie's like done. I have to get a new Sharpie every 2 days. If I'm lucky, I'll get 3 days out of it. Are you sure that's yours though? Because I don't want you to take a sip of it if it's actually mine, because I'm sick.
Why am I getting a food?
I can't remember. I thought I might have put it there, but I really am not sure. So, well, if I'm already sick, then I guess I could drink that one. Because, like, you're not sick, so. Damn, it's cold in here, dude. Are you not freezing? Damn, I'm like freezing right here. I feel like the AC, it's blowing directly on me, dude. Yeah, I actually don't want this stuff in my playlist. Like, I don't remember adding this. I don't know how it got in my playlist. It did though. And yeah, we're like, I don't want it in my playlist. I don't actually. I don't want it. I want it out. I don't like that. Okay, yeah, remove that one. And yeah, I'll just go one by one. If next time I hear one I don't like, I'm just gonna remove it. I guess I accidentally added like an entire playlist instead of a song from the playlist, and yeah. Okay, so let's jump back in. So we have step 7, receive side, sort of timestamp. And then we would want to apply the data. Apply data in order of timestamping. This would mean this will require restructuring of dir check, I think. Okay, so yeah, the goal here is to reflect exactly how it is changed on the server side to we're going to be changing it on the receiving side in the same exact order that the data was changed on the sending side. Yeah, so it's kind of dumb for me to have done it the way that I did it. I just didn't think it all the way through, you know. Not the smartest decision I've ever made, for sure. I should have saw that in hindsight, but whatever. I mean, I should have saw that in foresight instead of hindsight, but that's life. You live and you learn. Alright, so I'm pretty sure this is really good. Like, I'm pretty sure this will be the final version of our data transfer. I don't think we're gonna have to make any more modifications to it after that. At least for the data to be properly organized. So sending side, we don't really have to worry about like the order of the send on the send side. And I guess the philosophy with this is get it out as fast as you can. Meaning, you know, if it's like ready to be sent, send it. I don't think there's any reason to run like I don't think there's any reason to pause our dir check system, but here's what I think we are going to do. Well, I don't know. Should we do this? Let's see. And this is gonna fall under requirement number 2. So we have requirement number 1, which is apply each and every adder based on its associated timestamp value. Okay. And then we have our step-by-step. Okay. Alright, yeah, so as far as the dir check logic, put send dir check and receive dir check. Like, which do we need to modify the receive dir check? I would say, hold on, let me actually pull it up and look at it. So let's look at, well, it's gonna be the same on both, or it should be anyway. We'll just pull up the actual dir check call. And wait, what? Did I just like I passed over it? Okay. Oh, it's right here. Alright, here we go. It's because it didn't have the open quote. So as it stands for damn. As it stands for the current version of this, I think honestly all this is just gonna be basically redone. which sucks because I just redid all this. Damn, that sucks. Um, length of receive object dictionary. Okay, so then so some of this we're still gonna use, but some of it is gonna be scrapped or altered. Like, I think we can use all this that we have right up here. We say if ready ink data, we want to keep that. We want to keep this. It's like data times it was greater than 0. Wait, what exactly does the timestamp? Okay, the timestamp list is how does that work again? Let's see this. For 2-bit ink data, check timestamp list. Okay, that's our ink data, and that's when we're appending to it. And what does it consist of? It consists of the timestamp and the dir string, and that gets assigned as far as the sending. Okay, right here. This. So this is for the send. Beginning of send section. Because I always have trouble identifying that. Pens timestamp to. So we're gonna be. I don't know if we're even gonna use this because we're not gonna be getting this current time right here, and we're also not going to use the timestamp list because the purpose of the timestamp list was because we thought we could sort it based on the dir check, but we can't. That was stupid. And so that means we're not going to be using a dir check timestamp list. We're going to be using... We are going to be using a timestamp list, but that's going to be on the receiving end. Okay. So I'm pretty sure we're gonna end up getting rid of the dirt check timestamp list. So really, I think for right here, what we would want to do is not check the, I'll put this in my things to do, is wait a second to identify receiver change. Oops. What the hell did I do? So we have to restructure the transfer management. Implement second DTM restructuring to implement perfectly precise timestamp data application. Careful because I have like that little cold. I mean, it's up to you, but I don't know if it's like viral or whatever, contagious, but it might just be allergies. I don't know. Just figured I'd let you warn you just in case it is viral. It's not terrible, but it's kind of like aggravating. Not so great today. Which one do we need to do first? Do we need to restructure dirt check, or do we need to restructure data transfer menu? We need to. I think we need to remove dirt check timestamp list altogether. Okay, so as far as the restructuring of the dirt check logic, I don't necessarily think that needs to be changed, because like since we have the delay, it would already have time. We would have time on the receiving end to, you know, receive everything, even if it is out of order. Like we said, it's going to be organized on the receiving end, and as long as we add in enough of a delay, like, I don't know. I mean, would it be cleaner though? I mean, because that's really the question. I want it to be clean and like perfect. So I want to make sure that when we are like, we definitely would have to modify it on the receiving end though, because we already talked about that. Like, it has to be modified on the receiving end, but on the sending side, you know, I'm just realizing this. Like, couldn't we just make dircheck run? Like, the one function gets called, and it would run the entire. Like, it would check all of the data. It would check the player, it would check the game, it would check the deck, it would check the location. So instead of having 4 of these, we would only have 1. But like, that's still, we would still have that same, like, I don't want to call it an issue, but we would still have this same thing where data is like, data is sent not necessarily in perfect order, because we would still be checking, you know, the player, the game, then the deck, then the location in a particular order, and it still would be prone to that issue. So just thinking though, like, I don't think it's necessarily required for us to do that, but I think it would make sense for us to change that eventually. So I think we already actually added that in our things to do yesterday, I'm pretty sure, in non-pressing issues. We put 1x dircheck instead of 4x. Can give reason as to why we use 4x dircheck instead of 1. Make 1 large cell instead of 4. This could be accomplished by dir check being called 1x, and inside of the function it checks for player, game, deck, and location changes all at once. But so becomes 1x instead of function checks for player, game, deck, and location changes all at once. I was just thinking that there might be an issue. Well, I was just wondering, like, would it be slower? I'm like, no, because we already do that. Like, that's already exactly what happens. Like, all that we're doing is checking to see if all we're doing is checking to see if so, like, how do we determine whether or not data has been changed on the sending end? Well, we iterate through all of the filter directory and we see if the current value differs from the old value. But I'm just now realizing that we could use we could actually say that we could determine whether or not we need to send the data at all. Like, instead of checking everything in the filtered directory, yeah, we're iterating through the filtered directory in this case. But actually, since we're implementing the timestamp thing, we could literally just check for, we could check to see if the timestamp values are different. And this would be like a much leaner way to determine. You see what I'm saying? Like we could just check for the player instance, the player object instance. We could just say, okay, do we need to send anything associated with the player? How do we know we need to send it? Well, we could say, all right, here's what we're gonna do. We're going to check the timestamp dictionary values associated with the player object, and we're gonna just compare it to the previous version that we have registered, and if any of the values are different, well, that means something has been changed, and that's the data that's the data that we need to change, I mean to send over the network. But I don't know, like that. Let's see. Well, this is for receive. Let's go down to if receive is equal to false. Actually, I can just receive is equal to false if item is equal to card group data dict. Send yeah, so instead of checking like this, the length of it, we could just check to see if the timestamp is different. And basically we would have like just a list of these, any altered timestamp, that would be the data that we know needs to be sent. So like we don't have to check, we're not going to be checking every single thing. We would already know what we need to send based on if the timestamp is different. If the timestamp's different, well, we know we changed something, because whenever you change something, it updates the timestamp. So if we have a different timestamp, now we know, hey, we need to send card group data dict. But if it's the same, it's not going to be in our list of like changed attributes. So we can put this in things to do. We will put we don't necessarily have to have this as a pressing issue. This is something that we can implement later, because like I said, we don't want to change anything that we don't have to get the game back up and running. We can always just make those, that's like new ideas. We can always add that later. It's just a more efficient, leaner system. So we'll put 325.4, and This will be called the improved send data determination, and we'll put restructure the way that send dir check determines which data needs to be transferred. Let's just see exactly. How do we want to write this exactly? Instead of iterating through every single adder in the filtered directory, we could instead of iterating through every single adder in the filtered directory, we can instead iterate through the cl.timedict and compare it to a previous version. If any timestamps have been updated since we last checked, them, we know that the particular adder has been changed and therefore should be transferred. And that would consist of adding in that would be consisting of this would consist of adding in a list of a changed adder list, which is appended to during this iteration. If a timestamp for an adder is different, append that adder to the list, and then iterate through that list appending the changed data to the associated changed adder dict. And we'll put that this would eliminate extra time and processing power used checking various lens adders and other time-consuming logic that is currently in place. Okay. I'll put, as far as it being required though, I don't see any reason for us to have to modify the current system. But let me just triple check that real quick and just like, so this is for send. Like, is there any reason? Let's actually go to this section that says before send. Okay. So now before send, I mean, like, yeah, it doesn't really matter, I don't think, because all that happens when we run dir check is it checks that associated object, in this case the player object. If anything's been changed, it adds it to the change attr dict, the change player attribute dictionary, and so okay, here's one idea that I think could be beneficial. But this is something that's also not necessary, but would be cleaner. And that would be, instead of having multiple changed attribute dictionaries, like one for each object, we could just have just one change attribute dictionary. And I think that would be a worthwhile thing to do. Yeah, so I think that's something that we could definitely do. I don't see any reason to have 4 of them. So we'll put this in non-pressing as well, and we'll call this 1x changed attr dict put instead of having 4 changed attr dicts, use 1 instead. Okay. And this would eliminate well, this would be cleaner and reduce possible bugs by using less code lines, etc. Because the current system, well, the system that we're going to be using is it's gonna like gather all 4 of those up into one anyway on the receiving end, but it's not actually necessary for us to change it to implement what we're trying to do. So where exactly was I? Okay, that's right. I was trying to figure out if I actually needed to modify the current system as far as the send dir check. Let me just put current spot so I don't forget, just like I just did. I can just go back here, current spot. So receive dir check. Yeah, I'm pretty sure we will have to. Let me just put receive. Okay, but not not dir check. Like, we're gonna just minimize dir check. We don't. We're actually trying to look. So right where? Well, okay, I'm sorry, I'm an idiot. Actually, we do need to be looking in dir check. Yeah, we want to look in dir check, and we want to see it. Alright, so yeah, we want to look at this one for if receive is equal to true. This section right here. And so actually I need to start at the top, I think, because okay, so first off, the way that we call directory check, like when we go to receive it, when we go to receive everything, which is right here, this is where we actually start receiving the data. So what we do is currently we check for ready, we get ink data, then we check to see if the length of the timestamp list is greater than 0, which we're going to be getting rid of the timestamp list because this is going to be replaced. We're going to actually put a note here. It's 320.4. Quite sure we will be removing timestamp list But is that actually true? I mean, the timestamp list is... Well, no, actually we won't, because, hold up, because when we go to, check that one more time. Let's find dirt check timestamp list here. Let's put actually dot append. That's what we want to see. Okay, so yeah, this is actually fine. We actually could keep this because this well, like, we could keep it, but couldn't we just check the changed attribute dictionary? It would just take, you know, a millisecond to just check the attribute dictionary, because we're just gonna we're gonna get the data in, and then we're gonna say, okay, is anything been changed? And, you know, of course something should be changed, because it shouldn't even send it unless something's changed. That's like the logic we have. So it's gonna ask, with what I'm proposing, instead of checking dirt check timestamp list, we're gonna say, hey, let's look at the length of each let's look at the length of each changed attribute dictionary. And now I'm just wondering about this. Okay, so if we were to have one dir check, I mean one attribute dictionary instead of the 4, one for each object, wouldn't that mean that in the case where we were like, wouldn't that mean that we would be checking through more stuff? But no, because remember, we proposed that we would actually have, on the pre-send side, we would have a changed attribute list, and that list would encompass all of the objects. So then when we sent that list over the receiving side, we actually wouldn't need to check, like, we wouldn't need to check to see what data to apply at all. We would already be sent a list of things that are being sent. Like, it's like, we changed this on this side, here's the list of things that we changed, so you don't even have to look and figure out what we changed. We're going to tell you. It's going to save us computational power and time, and it's just smarter, it's less code, logical, etc. It's just better in general. That's what we should do. And that means that we would get rid of the dirt check timestamp list in favor of this in favor of this system. What do you think? I think that's very fair. I think that's the right way. So we're actually gonna get rid of the dirt check timestamp list. Now let's just give a final check to make sure that we're not going to need it. give it the discount triple check. And I'll put, since we will be using a pre-send list based on changed timestamps. Since we will be using a pre-send list based on changed timestamps, that includes, could call it changed adder list. A pre-send list, I would say a client attribute, instance attribute. We will be removing their check times and lists since we will be using a pre-send list, a client instance attribute based on changed timestamps. We could call it the changed attribute list that includes. Okay, let's quite sure we'll be removing just a pre-send list based on changed that includes all of our list of all changed adders values. Meaning that on the receiving side, we won't need to quote unquote check to see what data needs to be changed at all. We will just look at this list and apply that data. Okay, perfect. This is a we'll note. We're definitely was positively going to do that, so we're going to put down things to do. We already added that though, somewhere. I'm sorry. Dance right now. Okay, back. Uh. Okay, yeah. So we copied that note, and I think So we put. I think we need to remove dirt check tips. I don't think we'll be using it anymore. And put we will instead be using a pre-send list. Because list of all change items mean that on the receive side we will need to check to see what data needs to change at all. So let's just open that data. This means we need to be checked timestamp list at all. Yeah, so we like reasoned through that and verified that. Because you always want to double, triple check before you remove or add anything. And I'm learning more and more. It does suck, you know, like sitting here and just doing all this note taking. I haven't really written barely any code, but I think that this is actually like, you know, the fastest way and the smartest way to do it. So, yeah. So yeah, sender checking the series of rest of modifiers. Restructured data transfer management logic. Yep. So the question is now, like, well, let's finish working on this. The receive dir check. What needs to be changed for the receive dir check exactly? And that means like not. Let's see. The actual or the inside of the dir check, and then logic which calls receive dir checks. So we have the logic inside of dir check, and then we have the logic which calls the receive dir checks. Those two. And so yeah, David, you could tell your dad like we could just hold on to it for until my court date. And then after my court date, I can probably go back there and I could bring it then, which is on April 5th, so you can let him know. And you know, like, I'll definitely take it, and I can fit it in my car, so he don't even have to. Y'all can just like put it outside of here, outside of your house, and just stick it on the side of your trailer, and then I can load it up, you know, whenever. Because I already have one, but it's good to have a backup. If y'all are just gonna like put it by the road, I definitely would take it. Alright, so as far as the inside of dir check, let's look at that first. Well, no, I think first let's look at the logic that calls dir check. So we receive the data, and then we get the length of the receive object dictionary. We're gonna keep that. So I will actually go through here and put keep or remove. So we're gonna say remove, and this is also gonna be remove. This will be we're gonna keep that because we're gonna keep the receive object dictionary. Then I'll just actually do it this way. We'll put keep remove, copy that, and then we're gonna, as we go through, we'll do it like this. So we're gonna go line through line here. So we're gonna keep this one, and then this is gonna be, I actually put 2 because 2 means we're modifying. So let's actually copy that, and then if ink data, now this, I don't know about, I would say this maybe keep, so we'll just like pass out. Any ones we're not sure, we'll pass over. This, we're definitely gonna keep it. So that would be keep. This is just for comment. Keep, yeah, I'm gonna keep that. And then same for this, we're gonna keep that. This, we're gonna keep that. Now, well, this we're probably gonna remove because this is not how we're going to order the data at all. I would say this because are we gonna, so now the question is, are we gonna keep the order list? Do we keep it? Well, this is gonna exist, but it's gonna exist in a different format. It's not gonna be it's not gonna be the order list. We would be iterating through the so yeah, I'm not gonna like refactor the code. I would just get rid of it and redo it. So the purpose of the order list was to order the timestamps based on the and you know what? I can get rid of this, I think, now, because I'm pretty sure that we have it figured out as far as how we're gonna call the dir check. So what I'll do is I will actually get rid of this and I will move it to old systems file. Copy that and get rid of it. And now we'll open up this old new features, and we'll put old feature storage, and we add 4 lines between, and we actually want the long div, the div that goes all the way through. So let's erase that, and then this one, long div, and I don't know why that's so far indented. And I'll just put, I'll do it like this, we'll say. Remove 325, 24. No longer using this. We use 1x dynamically structured dirt check call instead. We'll just put a question mark, 3 question marks if we're not sure. This is keep, okay. This actually needs a div right here. And now for tube in ink data dirt check timestamp list. Yeah, so we were wondering, should we get rid of the order list? I was thinking we could restructure this. Because I hate to just throw this away. I feel like we're gonna end up using this, or a similar thing. Because we're gonna want the timestamp. We're gonna want the directory string, and we're also gonna want the length of the receive object dictionary. Which is the key of the associated value. Yeah, so we still would want to use this, I think. We would just rename the thing here. Like, instead of iterating through Well, okay, so actually we wouldn't if we don't have the timestamp list, um we don't have the order list. But what we could do to get the dir string would be, how would we get the dir string exactly? So we could check it on the receiving side, like, so on the receiving side, I'll put some notes here. I'll put, actually, I will just copy our steps here for receive side. Um, just like this, and let's okay, yeah, no, that's actually old. That should be deleted. Okay. So yeah, we're gonna copy all this receive side stuff, and I'll put it right here. And I'll put steps added, created 3, 25, 24, a copy of implementation steps from things to do dot text as a reminder for how we are changing DTM logic. Below steps of 3, 24, copy of implementation step. As a reminder for how we are changing DT logic. Okay. Well, let me know if y'all need a hand getting it in, David. Okay. So after receiving data, iterate through each change adder, accessing the associated timestamp for each adder via the receive client time dictionary. Append each timestamp to the timestamp list. Sort the inked choice using some function. Okay, yeah, we're actually changing how this works. We're gonna do this beforehand. So let me actually restructure these notes real quick. And I'll just put steps right here. Now, old feature storage. That's not what we want. Alright, so that's new direct things to do, and this is actually going to be different. We're going to say, or does you send create the associated timestamp logic for each adder, update the client time prior to sending data. Update the client time tick prior to sending data, and then we're gonna put ensure client time tick is sent, and then step 5 actually would be to, on the send side, we want to check the client, well actually this would be update, and then we'll say, well we actually, so yeah, we gotta restructure this, it's all good. Say update the client time tick. I'm trying to figure out where to put this exactly. Update the time tick prior to sending data. That's something we definitely want to do. Then we want to check the time date, check the new time date against the old, make a copy or something against the, check the new against the old to determine which adders have been changed. To determine which adders. Check the new client time date against the old to determine which adders have been changed. Yeah, alright, that's good. And then we want to populate the changed adder list during step 5 iteration. During step 5 iteration. And then we'll put this one, ensure that the client dot changed adder list is sent. So this means that we don't have to worry about doing this these steps on the receiving side. So 10, 11. Alright, so we can simply say, like, so after receiving data, we can change the receive side steps now. So after receiving data, iterate through each change attribute dictionary, accessing the associated timestamp for each adder via the received. Yeah, we don't have to do that because this is already done. So we'll just say access the client, the received client dot changed adder list. You can use that bleach spray but you just have to be careful because that's the stuff that it's in the bathroom on the top shelf on that. You'll see it. It's the white one. You can use the white or the green one, but the white one's like cheaper and probably stronger. But it's like very strong bleach. I fa it's like with bleach. Is that what it says? Oh, it's at least like 50%. Like it's a lot. It's basically bleach. Like if you get it on your finger, you'll feel it. It's like very high concentration of bleach. So after receiving data, access the received client changed adder list to get the adders that are going to be modified with the current sent. Or modified sent. Now, concerning this, so we access the received client.change adder list to get the adders that were modified / sent with the current received object. And honestly, I think we should probably remember it's bleach, David. So after receiving data, access the received client.change adder list to get the adders that were modified sent with the current received object. And this really we could concatenate this. We could say enter and adder list is sent after receiving data. Access the received objects. We just call it the ink data. Ink data's better list. We don't just want to access it. We want to store it. Store the adder list, and we'll put perhaps in a way similar to the changed, or what do we call it? The order list. Direct check timestamp order list. Similar to the way that is done. Data. Store the ink data's change adder list. Perhaps it was with tuples. to get the adders. And we'll put actually along with the received object. And where are we gonna store them? Like we could modify the received object list, or we could just basically have like a mirror version of the order list, because that order, like the thing that we're talking about, is gonna have I just actually put in a there's your timestamp order list mirror. After receiving data, store the data's check timestamp order list mirror along with the received object. Receiving data along with the received object. Okay. So yeah, that's good. And each timestamp to the ink timestamp was, yeah, we don't need that actually because we already did that. Well, no, I'm sorry. That's it. We actually do. We do want that. We want to store the changed adder list. And we can basically say that this would be the key. Store the data is changed client list. The key of the receive object in the receive object list. And we'll put it in the form of a tuple. Ink data change adder list. We'll just call this ink data. Store the adder list. Key of the receive object in the receive object list. So key of the receive object in the receive object list. And then the actual timestamp. So this is just how it works. We're just going to continue to tailor it more and more detailed, you know, more and more precise as we, you know, step by step. We're just going to keep doing this. I think we're on the right track here. I want to get it right before I implement anything. Like I said, I'm not going to change any code until I get my step by step completely finished. So when we receive the data, do we want to store, like, I don't necessarily think we want to, I think we could just make the receive object list. Well, no, we don't even need to do this because all we need is all we need to do is store it in the receive object list. After receiving data, store it in receive object list. And then we would, after that, what do we want to do? Well, after we have the receive object list, we then want to we have to figure out the timestamps and organize all that. So I think we might actually be on the right track with this. We would append each timestamp during append each timestamp and you know, actually we could do this on the sending side. We could populate the changed adder list since we're iterating through the so we're going to say iterate through the new, comparing it against the old. Old exists by making a copy at a prior point to determine which adders have been changed. Okay, and then we could populate the and this will actually could be the changed adder dictionary. So we'll say so populate the changed adder dictionary. So populate the change adder during step 4 iteration with the I guess we could say the oh shit, I lost my train of thought, man. Damn it. I had it. What was it? With the key and the value, I was going to do the dictionary. So we have the, not the change attribute dictionary. Hold on. Iterate through the time dict comparing against the old time dict. What is this to determine which adders have been changed? And we'll put this will be during step 4 iteration. Step 4 iteration. Populate the client. Alright, so let me just go. This is, we'll actually call this prep, and then this is gonna be prep, and this is gonna be exec, which is like execute, the actual execution code we're gonna use. Exec, 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 and then exec. So prep. Exec. So first, we're going to update the client time dictionary. Okay. And this would be at the beginning of, like, prior to dir check. We can just leave it as prior to sending data. Iterate through the new, we'll just say the updated client time dictionary against the old time dict. To determine which adders have been changed. Then, during step 4 iteration, populate the client changed adder dict with the names of the changed adders. Okay. Why is it a changed adder dict though? Because I accidentally changed, this is supposed to just be a changed adder list. I changed the name of the wrong one. So we're iterating through the client dictionary. Okay, so I actually did want to, okay, I remember now. So as we're iterating through the new time dictionary, once we notice that a time stamp is different, meaning it's been updated, since we're already grabbing that timestamp, we want to take advantage of that and implement that timestamp into the changed. So this will be the changed adder. Well, we can't really use that name because well, I'm trying to think of, yeah, I mean that's like, we could use that name. For now, I'll call it the attribute dict to be like just distinguished, so I'll know that's the one with the full attribute name is the one we're gonna be referencing when it's gonna contain all the change attributes. So populate the change attribute dictionary with the names of the change adders as the key and the actual timestamp as the value. Okay, that makes sense, right? And so I'll put key equals name of the change adders, and then val equals the actual timestamp, and then the next step would be so we're still on the send side, and then on the send side ensure time dict. So what is the, oh right, yeah, we want to, well, I'm like, yeah, well, we do need the time dict for that other purpose, but technically we wouldn't need the entire time dict for what we're trying to add in, because the the timestamps that we need are already going to be there inside of the change attribute dict. Now, for step 6, we would ensure the time dict and the changed attribute dict, we'll call it change attribute dict, is sent, are sent. And then receive side, after receiving data, store it in receive. Just put store ink data in receive object list, and then step 9, append each timestamp to the ink timestamp list. Yeah, we don't need that because we already have that. So we can just get rid of that completely. And this says sort the ink timestamp list from earliest. So we do need to sort, but hold on. Well, okay, so actually we do need, okay, yeah, we actually do need the timestamp list. We do need a separate one, because what we want to do is this is gonna contain the timestamps for like every single data point that has been changed. So this is gonna be like the list that a list which contains all changed data. A list which contains all changed data, and then we'll put which is depopulated as the data is applied. And this is gonna, I'm like, wait a second, so couldn't a list which contains all changed data, and we could say we would actually, this would be, how about this? This would just be a, well, would this better be a list, like a tuple, a list of tuples, or like a dictionary? I'm not sure exactly. I'm trying to think how this would work best. Getting a little bit sleepy. Getting a little crash here. I think I need to take a little bit more of my vitamins. Well, we're almost done with this part, I think, with the brainstorming part. Well, not brainstorming and our outline. It's almost completely finished. just reviewing all this, looking at it. Okay, yeah. So right now we're gonna we want to determine should the ink timestamp list be a list or a dictionary, and I want to say like it should be like a list of tuples, similar to the. Basically, this would be a mirror of the the order list. Say structured like the order list. This which contains all change data, and we so let me actually I don't like going too long. Let's back up, and then we'll add a sub step. A list which contains all change data, and then we'll put which is populated is depopulated as the data is applied as tuple, and we'll put the a list which contains all change data as tup. And I'm just like making sure this is the right way to do that, or am I errant in thinking this would actually work? And each timestamp so this would be so we would iterate through the ink data dot what's it called? Changed attribute dictionary. Append each timestamp. Because it's structured, the change attribute would have the name of the change attribute, and then the actual timestamp. Or should we have the change attribute be actually the change attribute list, and we would have a tuple where we had the name of the change attribute, the timestamp, and the dir string. And then like I'm asking myself right now, well, do I need the dir string? Because if we're going to well, yeah, we do, because we're going to yeah, that we still have to have the dir string, because that's what allows us to know which object we're accessing. So I think it would be wise for us to actually populate the change attribute, and we'll call it a list, and So we can actually call it change adder list. Or we can leave it as change attribute. It kind of jumps out at you. It's easier that way. And plus, to access it by the drop-down list, it will be faster because all we have to do is add that extra I in the middle of attribute, because none of the other ones have that. We have a bunch of changed attribute dictionaries, but only one changed attribute list where the actual attr I is there. So when we put the I, it will make it really easy to access. Okay. Now, populate. So we'll do this in the form of a tuple where we have the name of the changed adder, like the order. We can change the order of this, the dir string, and then the timestamp. So we just put the timestamp. So this is very similar to the changed the order list or whatever we were dealing with before. So we're actually going to change this. Is going to be change attribute list. So we're going to make sure the time dict and the attribute list are sent. Then we're going to sent along with client object. Then on the receive side, we're going to storing data in receive object list. We're going to iterate through the inc data changed attribute dictionary, which is actually the change attribute list, and we're going to append. During that, we're going to append we'll actually just say each entry to the inc timestamp list. So this is going to be like a reflection, this is going to be like a compilation. We'll say this is a compilation of all received objects, it's a compilation of all receive objects changed attribute lists. Changed attribute lists, yeah. Now, if I need to entry to the inc timestamp list, it's going to laser receive. And then, well, we'll just call this step 10. Oh, no, that's fine. Alright, and it will be a exactly structured, we'll put structured exactly the same as the changed attribute list. I think that's, and then step, we don't know what step this is gonna be, but we're definitely gonna do it, is depopulate the what? Depopulate the inc timestamp list as the data is applied. as the data is applied. Okay. But then we have to sort it, so that would go before this. Say, sort the ink timestamp list slash using a simple function. Yeah, that's would be exactly the same way I think as we did before. So we already have that code. Then apply data in order of timestamps, and then we would this would actually be a sub-step of 11, and we would, this would be 11a, depopulate the ink timestamp list as the data is applied. I'm sure there's something that I missed. Almost certain there's something I missed. One, two, let's make sure our numbers are right. So we got 1, 2, 3, 4, 5, 6. So this was 7, 8, 8, 9, 10, and then this is 10A. Okay, that's good. I'll be right back.
turn the light off?
Yeah. I'm about to move everything back. Yeah, that is. Put it in the shop.
That's the one from before where I'm not sure. Like, honestly, I wouldn't drink it if I were you. Because you could just like give it to your cat or something. I don't think she'll get sick. I mean, I don't know. I don't know if that's how it works.
That's an NBA player versus an NFL player.
That's why they like they used to the intensity make from it. Oh, keep it. As a mop towel. No, seriously, keep it. I'll use it as a mop towel for when I mop. You can wash it and whenever like I mop the floor. But that's how I prefer to mop actually.
I think it works better than the Swiffer. Because it's got like fibers, you know what I mean? Plus your weight of your whole body on top of it. It actually works really good. And honestly, I think that's the easiest and best way to mop the floor. Just with your feet, just wear your shoes. I mean, obviously, like you put your shoes on, and then just like easy. And all your weight is going into your body. Even on your back, like you use a Swiffer, it's like working a shovel. That's really nice.
I put some milk on the counter. Peanut butter. It's polar ice. It's like the light blue. It's the not spearmint. It's like what do they call it?
Alright, we're back. Okie dokie. Now. Okay. So I'll add this to the where I was in client, the steps, and so here we go. Let me just make sure I added the right ones. So 7. Yeah, from 7 to 10A are and this would actually be step 4A since it happens during the iteration. Put during iteration, and same thing with this one. During iteration. Right, back over here, that's a little cleaner. 7, 8, 8A, 9, 10, 10A. Alright, so first store the ink data in receive object list. Then iterate through the ink data changed attribute list. During the iteration, we're going to append each entry to the ink timestamp list. This is a compilation of all received objects change attribute list. Structure is exactly the same as the changed attribute list. Step 9, sort the timestamp list from earliest to latest using a simple function. From earliest timestamp to latest. And then apply data in order of timestamps. What do I mean? This would require restructuring of dir check. I don't know exactly what that means. Well, I don't know why I would. Let me see. So apply data in order of timestamps. Restructuring of dir check. Restructure. And then depopulate the ink timestamp list as the data is applied. Okay, now as far as what this means, apply data in order of timestamps and the restructuring of dir check. So that's what I need to look at now. Applying the data in order of the timestamps. So actually, I'll just keep going through. So forward to pending data timestamp list. Yeah, because this is on the receiving side. So this is already going to have been done. Well, actually, we would just change this to be, so it would say ink data equals receive, then we would put, well, I'll just go ahead and let's see. I'll just go ahead and remove this because we're not going to check for that anymore. Okay. Now we're going to, so we already did step 7. Store ink data in receive object list. That's done right here. Now step 8. Iterate through the change attribute list. So we're actually going to keep this though. We're going to keep receive object dict length of receive object dict and ink data. Okay. Then assigns. I think we would still need this. Move this up here, and so then we have ink data equals receive, then we do length of receive object dictionary equals the, and we say receive object length of receive. I mean, is that necessary? Couldn't we just put it like that? Is there any reason? Okay. Now this, I'm not positive that we'll need it, or whether or not we're gonna need that, but I'll keep it for now. Can always remove it later. Okay, now this is gonna be, actually I'll just go ahead and this we're gonna get rid of because we're not checking that. Okay. Now this will be moved up. Say creates ink data attribute dictionary. Yeah, this is for logging. So we definitely want that. And we can minimize that because it's for logs. Now for tube in dirt check timestamp list. So this is where we iterated through. So for tube in data dirt check timestamp list. Well, we don't have the timestamp list anymore. So really, we did step 7. Now we need to do iterate through the ink data. So yeah, we actually would be iterating through the changed attribute list, which doesn't exist yet. And then we're going to, during iteration, append each entry to the ink timestamp list. So this would actually be the ink timestamp list. Ink timestamp list. Append, where it's appending the 3 tuples, but the tuples are different now. So let's see how we structure it exactly. We're gonna do it in the form of, let's see, we could do it in name of changed adder dir string and then timestamp. We'd say timestamp dir string. Let's just paste this right here. And then we also want, so we'll say timestamp I guess we'll add this last, the actual changed adder, or we'll say changed We'll just call it adder name. So we'll have a fourth entry. Okay. What did I do right here at line 616? Oh, I remember why I remember. That's why I assigned that, because I didn't want to access it twice. Equals. Okay, so now we have the length of receive object equals length of receive object dictionary, receive object dict at length of receive object dictionary. Okay, and then using data. Wait, why do we have the receive object dict? I thought it was the receive object list. We changed it to the receive object dictionary. Hold up. Receive object. Why is it the receive object dictionary now? What? So before we actually started working today, what was it called? It was the... It was the receive object dict. Oh, that's right, because yeah, we use a key value and an integer as the key, so we don't need the index. Gotcha, I remember now. Okay. Okay. Alright. That is the... That's for logging. This might actually need to be changed. Well, no, it will whenever we change from 4 attribute dictionaries to 1, if we do that. Okay. So where were we exactly? Right here for 2 in inkdata.change. Okay, so we receive the data, we assign the length of the receive object dictionary. We do receive object dictionary at length of receive object dictionary equals ink data. Then we say if ink data blah blah blah. Okay, gotcha on that. Then this is for logging. Okay, then we say for toop in inkdata.changed attribute list. And actually, we can put the logging part. Couldn't we just put that like above? Yeah, I'm pretty sure we could put this, all this above, like right here. So we receive it, and then we say ink data adder dict equals so on and so forth for ink data adder dict string and ink data adder dict. Then we say adder dict equals It's a mouthful of all kinds of Then we minimize that because yeah, so that's fine to be moved up there, I'm pretty sure. Now, length to receive data, blah 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 for tube and data change attribute list. Timestamp list. So now timestamp list. Okay, so now we're iterating through the changed attribute list. Alright. So this would actually be changed to ink timestamp list append 2021 length of receive object dict and then the attribute name. So we're gonna say the adder name, and we get the adder name because it's 2021, and then this would be let me see exactly what are the three. It's name of change adder, dir string, and timestamp. So we actually want to do this backwards. We want to do timestamp, dir string, okay, let me try this again. Timestamp, dir string, and then changed adder. Alright, so yeah, toop using to name of the timestamp. Oh, wait, hold up. I messed up here. Let's bring it back. Okay, name of the changed adder, dir string, and timestamp. Name of the changed adder. And then name of the changed attribute. So timestamp, dir string, name of the change attribute. Timestamp, dir string, name of the change attribute. Timestamp, dir string, and then name of the change attribute, which is going to be toop2. So toop at index 2. So that's the timestamp, then the dir string, and then the attribute name, and put this, oops, to be more clean, adder name. So there we go. Populate CL change attribute list using toop timestamp, dir string, adder name. Timestamp, dir string, adder name. So yeah, timestamp, dir string, and then adder name. Alright. Now, get rid of that. Alright. So yeah, we iterating through the attribute list. We're appending to the ink timestamp list. The tube 0, tube 1, and tube 2. And we need to actually create the timestamp list. And what exactly is that? That is the let's see, ink timestamp. So this is a compilation of all received objects, and we'll put structured exactly the same as the change attribute list. So this is basically like the changed, the order list, because this contains all the pertinent data. So instead of the order list, because we're not going to be using that anymore, we're gonna have the ink, what is it called? Timestamp, what is it? Ink timestamp list? Oh, ink timestamp list, yeah. And this will be equals, and this will put created 3, 25, 24 type list is appended to in the form of tuples timestamp dir string, key of the associated receive object, dict client object, and then also the fourth value, which is adder name, for the purpose of storing receive data. Timestamps will then be ordered from earliest and will then be used to apply data via dir check calls. Based on this order is depopulated as the associated timestamps dir check has been applied, as the associated timestamps data has been applied. And we'll put, this is a compilation of all the received objects. Is it structured exactly the same as the change attribute list though? Because the change attribute list is the change attribute list actually have 4? Change attribute actually is not the same. It's timestamp dir string and then adder name. Timestamp dir string adder name. So I think that's how I want to do it. It's so it's not exactly the same. This is a compilation list of all receive objects, change attribute list. Structure is exactly the same as change attribute list, but with an added bless you. But with an added what? An added there's the last thing that's been added, and it's the thing that it doesn't timestamp dir string adder name. And what's the ink timestamp? It's not exactly the same because we added ink timestamp. Where's that? It's actually got the, okay, yeah, so we add the length of the receive object dictionary. So actually we're going to restructure that, and now this is actually going to be the last thing now. So we have the timestamp, the dir string, the adder name, then the length of receive object, which is the key of the associated value. And we'll put key of associated value. There we go. I haven't touched it. Okay, guys, so we have 55 minutes left. I'm pretty happy so far with the progress. It's not my best session. Well, I mean, it's a pretty good session actually. I am just upset that, like, you know, I kind of had to restructure this again, but it is what it is. Anyway, so let's keep going. For above line reference, and now yeah, that's lined up perfectly. So let's review again, make sure we got this right. Actually, the steps, it's not the same. Appendage tertiary, same. Adding the key of the client object in the key of the client object from receive object list as a final tuple element as the final. Yeah, sure. What? Oh no, I already got mine. You're trying to.
One new one in half. You must have never gave me one.
Wait, what?
I just ripped one in half.
Yeah, no, I just left those whole for you.
Oh, all of them.
Yeah.
Okay.
Yeah, I just like get. Yeah. No, you're good. Keep them. Keep the change, you filthy animal. Alright. During iteration of the change attribute list, we append each entry to the timestamp list, mirroring the entries exactly, but adding as a final tuple element the key of the client object from receive object list. Then we sort the inc timestamp list from earliest timestamp to latest using a simple function. We apply I don't know. Well, we are restructuring dir check. Ooh, I don't know. Anyway, we can remove that part, I think, and like I will know. So now we can actually copy these and put it back over here. So this is 10 through 7. So let's replace that. Alright, now why does the indentation get messed up? I'll never know. Okay, so now we're pretty far through actually this. And then for above line reference timestamp. Okay. Then we say dir check timestamp order list, which we're not actually going to sort that. We're going to sort the inc timestamp list. Yeah, sorts the inc timestamp list. So let me actually see if there's is structured exactly the same with an added element key of object in receive object list is appended to in the form of tuples, or we'll say consists of tuples times standard string queues and then add name, but that's actually not the right order because we changed that. We want it to be timestamp dir string adder name, timestamp dir string adder name, timestamp dir string adder name, key of associated value. Len file receive object dict more specifically, and this will, yes, we say is a compilation list at all. Key of receive object digger. Okay, and we're actually looking for the dir check timestamp order list to see if there was any remnant of it in this beginning section. Now, where are we at? I'm done lost my, okay, here we go. Okay, so right here it says appends each object timestamp. Well, that's actually wrong. So it says appends each entry from the received client's changed attribute list to the inc timestamp list in the form of tuples. Timestamp index plan. Nope, that's not right. Received clients appends each entry from of the received clients changed attribute list to the appends each entry of the received clients change attribute list to the inc timestamp list. In the form of tuples. Timestamp, that's not right. It's actually dir string. Actually, I'll just copy this shit. Actually, I gotta quit saying actually so much. So, okay, and actually, I gotta lay off of those phrases, words. Okay, yeah, that's good. Alright, let me review these notes. And receiving updated application. Yeah, that's right. I want to make sure I'm going line for line here and getting everything just right. Okay. Logging, create center. Yeah, that's fine. I don't need to worry about that. That's for logging. Then this assigns the current receive based on the quality. Okay. Yep. That's fine. And then this. So it appends each entry of the received clients. We'll just put of the ink data dot changed attribute list. To the ink timestamp list in the form of timestamp tuple a dir string adder name. Yeah, that's perfect. That's correct. Okay, sorts the. We're actually sorting the ink timestamp list using sort with the key param equal to a custom function, which sorts based on the timestamp value. Based on the timestamp value. No, remember that sort outputs in ascending order. I 1, 2, 3, 4, 5. Okay. Alright, that's good. And now this we can get rid of the 6. Alright. Now, come and create application section. Handles application and receive database on a timestamp order organization system. Alright. If length of not dir check timestamp order list, but of the ink timestamp list is greater than 0. So now we're checking to see after. Sorry, bathroom break again. Memories of Hogwarts, you dig? I don't think it's actually Hogwarts music, but it is pretty nice, isn't it? It's like very similar, because apparently you get copyright struck for even playing like actual, just like instrumental Hogwarts music. I don't know if that's true though, because I'm pretty sure I've played some stuff that technically could have been copyright struck, but wasn't. I don't know if it actually applies to instrumental. Alright. 38 minutes left, dudes. Let's try to finish this section. So, um, okay. Yeah, so this is good. And where do we stop? Okay, right here. If so now, alright, I just want to make sure this logic is correct. So we have if ready, we receive the data, then we log, we assign this cur or the receive string, then we say we iterate through the inc data's change attribute list, appending each entry to the timestamp list. Then we sort the timestamp list, which is good. That's yeah, because we only want to sort it if we've added more to it. Isn't that right? Yeah. Okay. And then we say on the same indentation as if ready. So this is whether or not we have received anything or not. Anything new, that is, which is what we want, because we don't want to apply. This was a bug we had when we implemented DTM the first time. Was it was only entering this section whenever we were actually receiving new data, which was like a gridlock bug. So we fixed that. Now this will be constantly checked whether or not we're receiving data or not, and we're checking the inc timestamp list, which is the correct list. And then let's look at this line, because we need to fix the comment, I'm sure. We'll read it actually. Assigns earliest timestamp to the first earliest timestamp from the order list, but it's not actually from the order list, it's now from the timestamp list. So it looks like we're going to end up just replacing order list with timestamp list, which is cool because we're actually not losing as much code as I thought. We're pretty much able to just go through and replace these names, which is making me really happy. Length of inc timestamp list is greater than 0, or the timestamp equals. Okay, yeah, this is going to be right, because it's pretty much the same exact thing. It's going to be the first entry, which has been sorted based on the timestamp, and then the first entry, which is the timestamp value. That's good. Then we say current time equals time. Why do we do that? Uh, let's read this comment first. Check to see if it's been 4 seconds since earliest timestamp. Okay, so then if current time minus, well, we actually changed this to 3 seconds. And then we say that works. And yeah, so we still want to do the 4 second thing. That's like, yeah, that's still a thing. That's still what we want to do. Create the apply list, which is used to apply any data from the, and we'll call this, we're renaming the order list to, it's going to be the timestamp list. Creates the apply list, which is used to apply any data from the ink timestamp list that was received at least 3 seconds ago. It's pre-populated containing the earliest timestamp entry, since we know that in this case it already has been 3 seconds since its reception. Okay, so we're checking, so none of the logic has changed. We know that worked because we already tested it, so we don't even need to review the logic because we already know it works. So the apply list equals the first entry of the ink timestamp list, and then we'll change this comment to reflect the new changes. Iterates through the ink timestamp list to filter out the data that has a timestamp of 3 seconds before, earlier, less than the latest, greatest, or timestamp. If so, appends the tube to the apply list to be applied. If not, breaks out of loop, since we know subsequent elements don't meet the 3 second requirement. Okay, so for tube in the ink timestamp list, we want to see if there's any more that reach that that have reached the 4 second threshold. If time minus time, or time.time minus 0 is same logic, so we don't have to worry about changing that. Else break, yeah, it's perfect. Begins iterating the apply list to apply third check data in order of timestamps. For tube in apply list, and then tube equals empty. Okay, this is different now. This is gonna be this. So we're looking at the, wait a second. Is this actually exactly the same? Let's see. Hold up. So for the apply list, how does the, okay, so yeah, the apply list is literally a mirror, like a subset of the ink timestamp list, and I actually want to put that, so we stopped at 639. Let's go back up here to apply list, and apply list equals, and we're gonna control F that. Oh, this is where it's assigned. Okay. And I'm gonna make sure to just put the subset of the ink timestamp list. So that's like a very easy way to understand what it is. It helps a lot when you can add details like that. Increase the apply list, which is use a subset of the ink timestamp list. Okay. Alright, so we stopped at 639 right here. Begins iterating the apply list to apply dirt check data, to apply data in order of timestamps. In Time order. Ah, whatever. Can't figure out the right way to word that. So below line, data transfer notification. Comment assigns current object to the dirchecks associated client object. Hold up. Okay, so now we're iterating through the apply list, and it says assigns current object to the dirchecks associated. Not to the dirchecks. To the associated client object. What is it? To the what? Assigns current object to the. Yeah, we can just say to the associated client object. For later data application, yeah, that's fine. And wait, is that tube 2 though? Because isn't receive. Hold up, wait, we don't use. Is it the received object? Yeah, it is. It is. Sorry. So tube 2. I thought. Zero, 1, 2. Okay. We actually changed this so that this is now going to be tube 3. Zero, 1, 2. So yeah, this is actually going to be tube 3. Because tube 0 is timestamp, tube 1 is dir string, tube 2 is adder name, and then tube 3 is the key of the associated value, and that's what we want. Let me just make sure these all match up where we have the comment and the structure correct. Timestamp, dir string, adder name, length. And this is for the timestamp, dir string, adder name, key receiver object. Yep, that's right. Okay. Now, okay, keep going. Yeah, that looks good. I think 26 minutes left. Objects. So where do we stop? I just want to make sure right here. Tube 0, tube 1, tube 2. Length of receive object. Timestamp, dir string, adder name, and then yeah, that's right. Okay, and yeah, so I think everything's good so far. Here has been 4 seconds, which actually is 3 seconds now. Current object equals receive object at tube 3. So yeah, we verified tube 3 is the right key, right index rather. Assigns current or other to string. Current or other, yeah, that's not going to be any different. And yep, so all this is going to be the same. Checks dir string is equal to player or game to determine object 2 arg. Okay. If tube 1, so this is going to be the dir string. Yeah, so dir string is still is tube 1. Yep, so that's good. But I'm not sure actually though, like are we actually gonna use this? Or is this like, is this, because we're gonna end up restructuring dirt check, isn't that right? I want to put where I stopped and I actually put right here. Okay. And I gotta review this real quick. I want to make sure we're doing this the right way. So are we still gonna have like, well, yeah, we are, because we still have to reference the correct objects that we're changing to access that object's attribute. So yeah, we still will need all of that stuff, at least for now. Maybe when we, now we're always gonna need that. Even if we restructure dirt check to just be 1 instead of 4, we're still gonna need like to like, is that actually true though? Hold on, because if we have the dir string already like in the the timestamp list, well, yeah, because because that's where we apply the data. Yeah, so we still will need that. I have this like feeling that we might end up maybe changing the name of dirt check or something. Cause I actually hate the name of that. I'm so sick and tired of saying dirt check. I feel like Tarzan saying that over and over. I'm sick of the name. So yeah, we're gonna need that for now at least. So we're gonna keep going on with this part. So the logic's still the same. We didn't modify anything here. Signs object to are blah blah blah. So I'm just gonna review this. We know how this works. We're just looking at the comments just to make sure the comments reflect the changes that we made to the various names. Here we have the signs object 1R, that's good. Toop 1, is Toop 1 still referencing the right thing? Yeah, Toop 1 still dir string. So none of the toops were changed except for this one. The current object is now Toop 3. Okay. So now this is signs object 2 since object 2 is always either. Yep. Okay, that's good. Currently, the search check call does not utilize yet, so that's fine. Mess with that. We need all that. Yep, that's still going to be the same. Okay, cool. Look at all this. We get to keep all this. We didn't really have to change anything there. 20 more minutes. 20 minutes to go. Calls search check with the appropriate arg. Toop 1, so that's still going to be the right dir string. Current object should be correctly assigned. Object 1 arg didn't change. Received. True. Object 2 arg. I know that changed. Yeah, so everything should be the same. Everything should be good to go for this. Deletes current iteration from the order list. Now this is going to be different because we're not deleting from the order list. We're deleting from the the timestamp list. Whoa! 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 Hey! What? 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 Psst. Psst. Oh. He's sniffing. He's sniffing. He's up. He's up. He made it.
Whoa!
I mean, I don't know if you care. Getting poo-paws. Poo-paws on the food area. Poo-paws on the food area. Poo-paws on the food area. Alert. Poo-paw alert. Poo-paw. Poo-paw alert. Alright. Delete ink timestamp list at index 0. Now, that's correct. And yeah, so all this logic is still the same. Like, honestly, I'm surprised that I was able to accomplish this. I'm still skeptical that it's gonna work, like, but everything seems like it's good. Creates the delete receive object entry. So this is the same exact thing. We didn't change anything with that. For order to, and we're not iterating through the order list. Like, we're wait a second. Yeah, okay, so no, this is not right. Yeah, this is not right because okay. Hold on. I just realized this. Actually, so okay. All right, so yeah, this is, remember when I wrote out that the structure of dirt check would have to be changed, and then I was like, oh, what did that mean? I don't really know, and I deleted it. That's why, if you don't know, don't delete it, because I put it there for a reason. I just forgot, but now I remember. So here's the problem. Whenever I run dirt check here, it's going to, when we talk about this a bunch, it's going to apply everything associated with this dirt string, meaning it's going to find every single attribute from the, let's just say player object, and it's going to apply all that, and we don't want it to do that. We have gone from that style of application to a one by one. Look up the boo. Look up the boo. You'll love it. It's funny. I mean, you don't have to, but it's just put boo, BUU, and then DB. Just type in boo, and it'll probably like be one of the first one. No, keep going. No. The next one, that one. It was pretty funny. I mean, I don't know. Were you that into DBZ? Yeah. It just, the episodes, the screaming, like it was just too long. Like they could have cut that stuff in half. Okay, let's get back on track. 14 more minutes. Let's do this. Okay, so dirt check is not gonna work. We have to So how are we gonna fix this? How are we gonna make it so that dir string will only apply one thing? Like we only okay, so here's what I'm thinking. I'm thinking basically we would just pass in a new arg to dir check, which will which is the whatchamacallit, it's gonna be the attribute name. So we're gonna say adder name equals, and we can get this through the toop, because remember now we pass, we have it as part of the, well, it's also part of the apply list, because the apply list is a subset of the timestamp list, and it's actually, we want the adder name, which is tube 0, tube 1, tube 2, and just to make sure, is that correct? Tube 0, tube 1, tube 2 is the adder name, and the apply list is a subset of the inc timestamp list. So yeah, we are actually good. So it's tube 0, 1, 2. It's tube 2. Where were we? What line? Okay, so tube 2. So now we have to create we have to go to where dir check is defined. So we'll copy dir check and put def dir check, and now we're gonna add this new param in, which is adder name, and then we'll just leave it like that. And okay, so we got 11 minutes left. And then finally is the adder name, and put equals, so it's going to be adder name equals the attribute's name, or the adder's name, the adder that we are handling's name. Very straightforward, easy. Okay, now we just have to add code into dir check. So we need to say if dir check is equal to game defined blah 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 blah. Okay. Where do we, let's see. Okay, so for item in a directory, so we're not actually gonna be using a directory for if receive is equal to true. So all of this is gonna end up being changed, and I'm gonna add this to things to do. And I'll just put a note here. This needs to be done. and then we'll put things such as a dir for receive are no longer going to be used. Instead, we are passing in a new param called adder name, which is the adders that's being handled name. We're passing in a new param called adder name, which is the adder that's being handled's name. Okay, and we got 8 more minutes. Okay, logic which calls receive their checks, and we'll put needs to be reviewed. And now, so we got rid of that. Needs to be reviewed further. Again, just put again, as we kind of already did review it. So this is really good. I'm really happy with the progress so far, but let's jump back over so we don't waste these last 7 minutes. Where are we at? Okay, we're handing that on the name. Okay, so now I guess I won't do that this time, because you know that's gonna be stretching it. We're not gonna be able to do that because I'm gonna stop. You know, I might actually, like, I don't know, I could go longer today. I feel energetic. I feel like I could go a little longer. We'll see. Anyway, so we're just not going to take care of that this moment. We'll hold off on that. We are going to go down to right here, and so this line I don't think we're gonna use. Isn't that right? Like, we're not gonna use this. I don't believe. Well, we can't actually. Oh, thank you. We can't actually iterate through ADIR. We instead would, and I'll put this in to do. Need to do a line by line review, restructure. Okay. So, like, damn, I don't want to just remove this, but we're not gonna be. What about for send? Are we gonna use it for send? Because send, it's gonna it would check, and I'll just put this as notes. I'll say for item in ADIR at line 164, item in ADIR at line number 164 in CLI, I believe, will be completely removed. for receive? And then what about for send? So for receive, yes, remove, because we won't be iterating through the changed adder dicts anymore, but are using the inc timestamp list instead. Okay, now for send, I think yes, remove, because we also won't be iterating through the filtered ders anymore, but will instead only be checking the times cl.timestamp dict. Okay. Okay, so we got 3 more minutes. 3 more minutes. Okay, I think I know what to do here. Since this is going to be such a big change, what we'll do is I'm not going to change anything in the only thing I changed in this dir check function was I added the adder name param. What I'm going to do, I think a smart way to do this would just be to copy the entire thing, and then I can make sure this is all getting copied. Okay, that's cool how that works. So if you like highlight that line, oh, so I could collapse this whole thing and then like copy it that way. That's pretty cool. I didn't realize I could do that. Let me just make sure I have the entire thing highlighted. What you looking for? I know that feeling. I know that feeling. I hate that. I'll walk to the room and be like, I'll get in there and I'll be like, what the fuck did I come in here for? Fucking Joe Biden's up in here. Okay, so this is a cool thing. I just learned this today. I was days old when I learned you could do this. You could just collapse the entire 200 line function and copy it like this. Now, whenever, and now I can just, I'm gonna double it by pasting, and look, it pasted the entire thing. That is really cool. Yeah, so now we can collapse this again. And we'll put a note. I'll put 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Stopped here. 1, 2, 3, 4, 5, 6. This is the. This is the. Or a copy of dir check which we will work on to restructure it according to recent data transfer DTM changes. And now we're gonna comment this one out. Oops. What'd I do? Okay, I see. Did it comment? Okay, well, unfortunately, it doesn't comment out. Oh, wait, I know why. It actually would. Hold up. So, if I comment just like the entire thing and then comment it. Awesome, dude. It comment. That's cool. Now I learned that today. That's cool to know. And I'll put below function being replaced by above, keeping until I am 100% sure replacement is valid. 3, 25, 24, and same thing here. Go up to. How do you like? Isn't there a way to? Like when those little dots appear. I don't know. I was thinking there would be a way to expedite the going to the top of a function. Okay. Alright, so this is where we're gonna stop. I think I am gonna stop here, and we'll put so we're gonna go to things to do. We're gonna update this. We'll put structure, check logic, sender check. Okay. Yeah, that, yep. Actually, that's not where we stop. We stop right here. Environment, step-by-step implementation. Still needs to be restructure the code and certifies ETN to reflect the modified changes due after okay, and then we'll put, damn it, finish restructuring code in ETM code in client file. Well, actually, I mean, sure. Okay. Outline, brainstorm, solution. There we go. Okay. Now we can go to devlog and we'll put, it's going to actually be closer to 4:15. So we did 5 hours, and this was actually, we did till about, honestly, till like about 2:45 probably, something like that. Brainstorm possible solution. And outlines. Here's the budget. And then this would be 246 to 410. Begin refactoring existing IDTM code to reflect new system. Give line by line review and update each one accordingly. Mostly finished list. Begin review of third check function inside of begin review inside of third check function. Okay, and yeah, that's it. So this is a really good day, I would say. I'm happy with the progress. It was a lot easier. Like, I'm seeing that, you know, I really just ended up renaming a couple things, and yeah, it was nowhere near as big of an L as I thought it was originally. So yeah, we updated things to do, we updated devlog, we copied devlog, now we're going to cd to the parent directory, we're going to get branch, we're in secondary, now we're going to get add, that's where we want to be, so don't worry about that warning, that's fine. Now we're going to do git commit m, and these I have to fix. Alright, now we're going to do git push Canasta secondary, and we did 612 insertions, 116 deletions. That, okay, well actually lots of that was by doubling the dirt check code, so it's kind of, you can knock off like 300 lines from that, but honestly, I don't know how that's possible. Oh, that's because of all of our text and stuff in the devlog and all that. But hey, I mean, lines are lines, dude. Lines are lines, bro. I put in some work. Okay. So we pushed, everything worked. Now we need to do the local backup. So I'm gonna go to programming. Actually, you set this up, that little blue icon is where Google Drive will now automatically back this up, but I'm just gonna be like extra safe, and we're gonna do our own backup just to be safe, because this is my baby project. This is my only project. This is the one that I've been working on for very long. So let's just check the devlog to verify. Yep. Alright, that's from today, so everything's updated. Now we're just going to make the name reflect the date of today, which is going to be 3/25, and that's it.